All right, so 4.2, this will be a pretty quick little section. It's mostly a special case of an exponential function, and it's called the natural exponential function. Um, and so let's talk about this number e. You probably have seen this before in algebra class, but you may not have used it very much. It does come up a lot in calculus. So if you're going to take calculus, you'll need to be comfortable using and working with this number or this function that we're going to talk about. But basically, this number e, you can think of it kind of like pi. It's an irrational number. Um, and so this is defined as the value 1 plus 1 over n raised to the n as n becomes very large. And so if you plug in values of n, you can see when n is 1, this value is 2. Then when n is 5, it's 2.48832. And we can go on, so on. You can see it kind of converges to this number here. This is a good approximation to 5 digits. So 2.71828. It's not important that you memorize it. It is probably important that you know approximately what it is. So I mean 2.7-ish. If you know that off the top of your head, kind of like pi 3.14. That's probably good enough. Their calculator is going to be doing most of the legwork here, but just so you have an idea of where that comes from, and an approximate value is probably good. So the exponential function is just the natural exponential function, I should say, is just the exponential function where the base is e. And a lot of times this is referred, like if you ever hear the exponential, like just the exponential function, we're talking about e to the x. So let's see how to do this on the calculator. So this is just a couple of basic calculator things. So on your calculator, you will see a button that has log. You will see a button that has ln. At least on my calculator, the log is on top, but it doesn't matter. But the ln button, if you hit second ln, you'll see e to the x with that. Second log is 10 to the x. Probably don't use that one very much, but you will use this one. So e to the x, second ln. And so when you do e to the third, and I put these on here just in case you haven't seen this, you can make sure that you know how to do these. So e to the third is 20.08554. 2e to the negative 0.53 is 1.17721. And then e to the 4.8 is 121.51042. So no reason to do that other than make sure that you know how to calculate these. Nothing too tricky, but it is something you want to make sure that you know how to do. Okay, so besides looking at graphs, so first half probably of the homework at least is looking at graphs, kind of like you did in the first section of 4.1, where you're just kind of shifting it and talking about the domain and range and all that stuff. So no need to go over that again. You can use the same method that we kind of did that in 4.1. But we do have these several word problems like this where we have, I mean, this is a very complicated function and not one that you probably will be able to graph by hand and not expected to. So if one of these problems does show up on the test, it would just be these two parts to it. We're not gonna talk about the graph as far as the test goes. But on homework, you do have access to the Desmo's website or whatever website you want to use to graph these things. So we can look at that. But this one just says an infectious disease begins to spread. City of population 10,000. After T days, the number of people with the virus is modeled by that function. How many infected people are there initially? So we're just going to find V of 0. So you have 10,000 over 5 plus 1245 e to the, I'll just write 0. Exponent is going to be 0. So essentially this is 10,000 over 5 plus 1245. E to the 0 is going to be 1. So 10,000 divided by 1250. And so we get 8. So initially there are 8 people infected with this. And then it grows, and you kind of think about these things as far as the graphs on the homework are going to be multiple choice. If you think about what the problem is talking about, obviously this is going to be an increasing function. You start with 8 and then it's going to increase and probably fast in the beginning and then it's going to slow down. But not every graph will look like that particularly, but you can probably make an educated guess on what it will look like based on the situation. So just keep that in mind when you're doing the homework. But you can easily graph it um, with a website, not by hand. Find the number of infected people after 1 day, 2 days, 5 days. So t equals 1, t equals 2, t equals 5. And so when you do this, and depends on the calculator, of course, some of them could handle this all at once. Others you might need to, take it more step by step. But we're just plugging in 1, 2, and 5 into this function. If you do it all at once, make sure you put parentheses around the denominator. And let's see what we get. We should get 20.966. T equals 2. We should get 54.37. And then when t equals 5, we should get 678.13. So we see it's increasing as we would expect. And then when you put this in the graph, this is what it comes out to. Make sure when you do the homework, I mean, the reason I put this on here is really just when you do this, make sure that you pay attention to the parameters of the window. So in this case, the y would go from 0 to 3,000, the x would go from 0 to 12. So that makes a big difference in how it looks and which graph you're going to pick. The other thing is it will ask probably the next question, and I don't remember, I guess I didn't put that one on here, but the next question probably is where will this disease top out? So basically, when we get out here, what's the maximum number of people that are going to get this disease? And so you can imagine when t gets really large. So if you imagine t going to infinity, e to the negative infinity, which is what that would be, negative 0.97 times infinity. That would be negative infinity. So e to the negative infinity is going to be 0. So that term is going to go away, and we just have 10,000 over 5. And so as it gets out here, it is going to go to 2,000 or 10,000 over 5. So that's how you do that. So really on the test, probably that one, and then what's going to be the what number is this valid function going to approach. You only have to worry about the graph on the homework when you have the graphing calculator or the website. Okay, but this pretty easy section. So if you have any questions on this one, feel free to let me know.